Okay, in this video, I'm going to walk you through putting together the full adder based on a half adder. All right, so we talked about this in class. We went through the truth table. You take the inputs x and y. I call this the carry in bit for the full adder. I'm going to go with the book's notations that were really consistent when we write this code. So this is x, y, z. Z is the carry in. And then we get outputs s and c. All right, so that's the truth table we did in class, and if you'll remember, we proved that you could implement that truth table using two half adders, right? So this dotted line here is one of the half adders, and this other dotted line is the second half adder. If you'll recall, this is the half adder circuit. So that's the setup. This is the circuit we want to build, and we've already written the half adder module. So the half adder module, I put it just in a box because at that point, once the module is written, we don't need to know the details that are inside the box. And so we can abstract that to a higher level. We have inputs x and y, outputs s and c. We instantiate that twice. All right, and then the next thing we do is I redrew this circuit so I could put in a little bit more information that would help me write this Verilog code. So I'm looking here. I know that x goes into x, y goes into y, z goes into the y input of the second half adder. But then I'm also going to connect the output of the first half adder to the input of the second. Because there's a connection there, I need to use something to connect it. And in circuits, we use a wire. So that's the concept of the wire in Verilog. So I would need to label that so I could include that in the code. So I'm going to have a wire going from S to X, all right? I also have a wire going from the output C to the input of this OR gate. Another wire, I label that CW1. I label this CW2 going into the second input of the OR gate. The output is C, all right? And finally, we have this output SW2 that connects to the output S, all right? So we now have the diagram set up, and that lets us easily write the code. So we're going to call this full adder, and we go through our usual process. I encourage you to pause the video, try to write as much of this as you can using this notation, and you can check your work, all right? So what I know is I have an input, all right? The inputs are x, y, and z. I have outputs. The outputs are s and c, all right? So I'm missing a comma here, and if you recall, there's not a second comma there. I have an open bracket, closed bracket with a semicolon at the end. All right, that's starting a module, so I need to end the module. All right. Next, what I want to do is instantiate both the half adders. All right, so we've talked about this, but this is a little more complicated than what we've done. So we say half adder, the module name. I give it a label. I'm going to call it HA1. And now I'm just looking at the inputs on this first half adder. I've got x, y as inputs, so I put dot x, and that's connected to input x. All right, and then the input on the half adder is called y, so I put dot y. You can check that in the code. The input is y, x and y, all right? So you need to be really consistent with the code and your diagram so you get the labels right. All right, so dot y is connected to y, so put y in parentheses. All right, so those are the two inputs. Then I have the output s. Dot s is the output, and I connect that to SW1, and I have dot c as an input, and I connect that to CW1. All right, I'm checking my brackets. All right, and add a semicolon. All right, so I've instantiated the first half adder. All right, so if you're watching and you were stuck before, pause the video, try to instantiate the second half adder and then check your work. Okay, so here's what you do for the second half adder. It's still, the module's named half adder, so I'm making a second copy of that, a second instantiation. And I look at what is the input connected to. X is connected to SW1. So .x, SW1. Y on the half adder is connected to Z. Okay, so .y, Z. The output of the half adder, .s, is connected to SW2. The output of the second half adder is connected to, the output of the second half adder, C, is connected to CW2. Okay, so that's the inputs and the outputs. I close the brackets, have the semicolon, and that's great. We've instantiated these two things, and now we just have to assign the outputs to complete this module. So we can assign S to SW2, looking at the diagram, and we can assign, spelled that wrong, C to be CW2 ORed with, the OR operator is a vertical bar, CW1. All right, so at this point, we've finished the code for the full adder. All right, so from there, we're going to connect those all together to form a ripple adder. But first, we'll run through a test bench to make sure our full adder is working correctly.